We're started. Good morning. Everybody got the paper at the door? Yes. All right. So today we're going to do dot products. It's a physics thing. Just accept it and move on. The reason we use it, and believe it or not, this was on my final exam for linear algebra last semester. The only problem is I had to prove why the dot product worked for vectors using matrices. The only problem is he didn't assign a single dot matrix problem. I knew that if you multiplied them and they were perpendicular, they would give you 0. The only problem was I had never worked one. Well, I haven't worked one in like 30 years, and well, I have. The correction, I worked on 5 years ago when I taught this, but I had never proved it, so I was a little bit baffled. So it's real. It's something that you have to do if you're going to go into physics and engineering, but you're in pre-cal, so we have to teach it. This is when we teach the basics. The only thing you need to know about dot products right now, because there's a great deal to it, but we're going to focus on the skills you would need if you ever need to actually use this in a class, and that is dot products. If you multiply two vectors, if you dot product two vectors and it equals 0, it means they're perpendicular. Okay? And that was what I was supposed to prove in linear algebra. And I knew it was true, and I knew it before you even said it, but the problem is I didn't know how to prove it. I'm applied math. I'm not theoretical math. So that's one very common use of dot product. The other thing is you can find the angle that way. It's another way to find the angle between two vectors, which is kind of cool because instead of right now, all you know how to do is find the angle of a vector, the direction. So you would have to find the direction of both of them and then figure out what's between them. So you'd have to find two angles, right? And then subtract them. Whereas this method, if you do this, all in one step, you find the angle between them. So it's a shortcut. It's kind of handy. It comes in really handy in physics, which means it's really handy in engineering. Really, really handy. Because you're always trying to resolve forces or vector properties, and you're always looking for angles between things. It always happens. So these are the two big skills for this. We're not going to worry about applications. We're just working on laying some foundation for you so if you ever have to use this, you got the skills. Or it comes back quickly. Okay, the examples already work. They're straight from the book material. And let's just go through what they're doing on each one of these and the important stuff. So I'm going to highlight stuff. So the big deal here is that every single time, that doesn't look very good, does it? Kind of hides it. I know, but it doesn't look very good. So we're just going to go with pen and red, and I'm going to underline. So basically, this is the important formula. I will give it to you. And this is the important formula. And a dot product means, and you know how there's the little A1, B1, A2, B2? I don't like that. I much prefer to make it really clear to you, where it's instead, this is X1, Y1, so it's the X and Y for the first vector, and this is X2, Y2. I much prefer that notation because it's what we do all the time and what you're used to seeing, especially when you do, thank you, it's what you do when you do slope, right? So I much prefer to use that notation. So when we rewrite this, we're going to rewrite the dot product. The dot product, and let me move this out of the way. The dot product, so I have the vector A, and then it's a big dot, it's like times but not times. Because it's vectors, you're not really, it's a little different than multiplication. What you do is you multiply these are the x's. So it's x1 times x2, and then it's added to losing my mind. There we go. It's y1 times y2. That makes it a little easier for y'all. You don't have to learn some new notation. Does that make sense? So the book uses A1 and B1. I like x1, y1, x2, y2, because y'all are used to that notation from slope. right, from Algebra 1. All the way, we've been using the same notation. I don't want to change it. Okay? Everybody got that? Is that pretty straightforward? You can do that? If you notice what's happening here, it's the dot matrix, and what are these two things down here? I prefer the notation with double lines, but what is it? Are those magnitudes? So what you do is you want to find the angle. The cosine of the angle is equal to the dot product of A and B divided by the two magnitudes of A and B. So if you can find the dot product, and you can find magnitude of A and magnitude of B, can you find the angle by doing inverse cosine? Yeah? That's what this is. And you're going to have a calculator for this. And I'm going to give you the formulas. You just have to show me you can use them. Fair enough? Okay. So let's go through an example. They gave us, so this is x1, that's y1, this is x2, this is y2. So to do the dot matrix, the dot product, you multiply the x's, you add it to the multiple of the y's. So do you see that that's, oh, I forgot one thing. One important thing. Look right here. This is the important thing. Remember how I said that we use it to see if things are perpendicular? Their dot product is 0 if they're orthogonal. Orthogonal means perpendicular. Can someone get the door for me, please? Thank you. All right, so if they are perpendicular, then the dot product is 0. Because think about it. If they're perpendicular, what's their angle? And let's do radians. It's pi over 2, right? What's cosine of pi over 2? 0. Do you see why, if their dot product is 0, they are perpendicular? Because the angle is 90 degrees, or pi over 2. All right. So we can prove things are, that's the first thing you're going to do, is prove things are orthogonal or not orthogonal. So on this other one, did the dot product, so we had the x's multiplied, and then we had the y's multiplied. You get, that's going to give me 32 minus 30, so it's 2. Is that equal to 0? No, then it's not orthogonal. So that's one thing that's going to be in your test. You literally have to use the dot product formula. If it equals 0, you're going to tell me it's orthogonal, or you can say perpendicular if you don't like that word. But that word's going to be in the question. And then if it's not equal to 0, you're going to tell me it's not orthogonal. And y'all are just going to practice that. Then there's find the angle. All right. So on this one, remember that this is x1, y1. This is x2, y2. And we have to do the dot product, and we have to find the magnitude. So first we're going to do the dot product. That's this first part right here. So we're going to do the dot product, and that dot product, u dot v, is going to be equal to the x's multiplied. What are the x's multiplied? 5 times -2, right? And that's going to be plus, yeah? Am I using my formula right? Yeah, of course I am, but can you tell me I am? 1 times 3. Well, is that going to give me the -10? Is that going to be 3? That's where they got this from. So they got that from this formula right here. So they did this right here. They did that right there. All right? Now we have to find the magnitude. So for the magnitude, so if I want magnitude of u, how do I find magnitude? You remember from yesterday? Square root, because is it distance? Is it just Pythagorean theorem? What's the delta x for u? 5, and I'm going to square it. And then what's the magnitude of the delta y? 1, and I'm going to square it. What's 5 squared?
25.
Plus 1, this equals square root of 26. Magnitude of v. Square root of what is v's delta x?
-2.
-2 squared plus what's delta y?
3.
What's 2 squared?
4.
What's 3 squared?
9.
What's 4 plus 9? See where they got their magnitudes from? Does everyone see where they got it from? Over here. These magnitudes. Got it from there, right? Last thing. If we have that, can we put it in the calculator? And that this is messed up. That's supposed to be an inverse sign there. I don't know how it got messed up, but it did. So for the cosine, so we have cosine of the angle is equal to negative, what's negative 10 plus 3?
-7.
-7. All right, now I'm going to make you do a little number sense, just a little bit. Is 26 double 13? So could I write that as square root of 2 times square root of 13 times square root of 13? Just to get some number sense in there, just because I have to. What's square root of 13 times square root of 13?
13.
So this is going to be 13 square root of 2, just for practice. And then to find that angle, do I have to take the inverse cosine of that ratio? Yeah, I do. So I'm going to do cosine inverse of -7 over 13 square root of 2. And when you do that, you get 112. I didn't record any of that, did I? Or did I? I did. Where is it at? Oh, here it is. I see it. Okay, I want to pause a minute.